Hello, good morning, everybody. So, how was last night? How were the drinks? They were okay? Good. Is everybody ready for talking about shared libraries this morning? Because I'm here to talk, but I expect something from you as well. So, I expect some interaction. So, first of all, my name is Willem, and I'm here to talk about shared libraries, why they're good to do, why they're good to share between microservices and teams. But we're also going to talk about why they're probably not a good idea. So, why are your shared libraries ill, and how can we cure them? First of all, who recognizes this? Sonar tells me I have code duplications. Well, I see a lot of hands. And it's even worse. It says Sonar tells me we have code duplications. So it's not in one project, it's over multiple projects. This means that we have the opportunity to create a shared library, the opportunity this is like Madame Tussauds. Yes? We have the opportunity to create a shared library. And wow, now we can create a shared library. We need a new repo. We need a new repo in our GitHub or our GitLab or anything where we can create a new repository. And you and me, we are going to create that repository together. So if we're going to share something, we don't want it to end up like this. Sharing some code, sharing a library, we don't want to end it up like having a fight over the library. Who decides actually what the functionality will be that ends up in the library? Who is to blame when there's a fault, when there's a bug? Is it your fault? Is it my fault? Whose fault is it? And who's going to fix it? What we actually want is two of those sweet little children sharing a drink together. This is what we want about a shared library. They share, they don't argue. But does this always go like that? Do we need something to agree on to get it in this way? Yes, we do. But eventually, we started with the will to share, the will to work together. And that's what I want to talk about today. So the will to share. Nobody likes code duplication. So that's what we want to reduce. We want to reduce the code duplication. We want to look, is there anything we can share together? We can develop together in one separate component. We don't want to reinvent the wheel. So if somebody in the audience created something very cool, put it in a library and share it together. When having shared code, probably will have better code quality, because if we share it together, we'll test it together. If we have multiple microservices where we use those shared code, it will be tested several times. And it will improve the code quality if we write tests, right? It probably reduces the bugs. It probably will, if we use it in the correct way. It will speed up bug analysis, because if we're with multiple teams, 10, 20, 30 people, yes, we can work faster to reduce, or to speed up the bug analysis, sorry, not to reduce. That was the previous one. And we're improving knowledge sharing. So if we look at the shared component together, we're sharing knowledge from the start. And that's a good idea, sharing the knowledge. So I told you in the beginning, there are also some reasons why we don't want to share a library. We have tighter coupling. So if both microservices are sharing the same shared library, we're coupled together. Nevertheless, even if it has its own lifecycle management, we do couple. We're less technology independent. So if I write a Java component, the other one must use it in a JVM. We need more coordination. What are we going to put in the library? What are we not going to put in the library? And we have a shared responsibility. And who can tell me what is a shared responsibility? Exactly, no responsibility. Thank you. So how are we going to solve that? That's the hardest question. And it's not exactly the question I'm going to answer in this talk. I'm not going to talk about how you're going to need to set up your teams, or do you need a core team to put that in place and to make sure that someone is really responsible and accountable for the shared library? No. And there's a risk of white box reuse. Who knows what white box reuse is? Oh, that's not a lot of people. Good. Then I can tell you what white box reuse is. If a library is handed over to you and you read the documentation, something like a Java doc or something like a user documentation, and this is sufficient to use the library, it's black box reuse. You don't need to open the complete library and look at every method and every API and every interface on how to use it. If you have to open every class and every single interface, you're actually reading the complete library, and that's what we call white box reuse. And white box reuse is not a good thing, because it means you missed something in your library. Why is it that people are opening the complete library and looking at every class? There's Javadoc. Why haven't you looked at that? Is it insufficient? What's wrong with it? So let's start with this. Microservices should follow the shared nothing approach. Do not share anything between two different microservices. And I got a question for you guys. So who has created a shared library before between different microservices? Well, that's a lot. It's a hot topic. Cool. And can anybody tell me what should be part of the library? Sorry? Versioning should be part of the library. That's correct. Yes. Anybody else who has a suggestion what should be part of the library? Documentation. Yes, I've mentioned that before. That's correct. Anything else? Specific domain logic. The domain of the shared library, so it's more of a documentation, explanation what it's for? Okay. Yeah. It's a little elaboration on the documentation, that's fine. That's good. Anyone else? I saw a lot of hands going up. Tests? Yes, that's good. Tests. And now one question, what shouldn't be part of the library? Have you thought of that? Logic, what kind of logic? Any kind of logic. Sorry, I did not get that. True. So I heard there should not be any logic in our shared library. I agree on that, partly. But let's go into details. So I want to talk you through my 5 good habits on sharing a library, creating a shared library. So who am I? I'm Willem Cheizoo, and I'm going to talk about my 5 good habits. And I'm a software engineer at JDriven. It's based in the Netherlands, and it's a Dutch consultancy company. And currently I'm working at the Volksbank. It's a bank in the Netherlands where we have a core team. I'm a core team member. And what I do is I create shared libraries for teams. And currently we have over 30 teams with over 200 microservices sharing the same shared library. So, 5 good habits. Number 1, avoid domain logic. I heard avoid logic over there, but I'm going to tighten it a little, be more specific, avoid domain logic. Let's look at a microservice architecture with domain-driven design. Every microservice should have its own bounded contexts with its own aggregate roots and probably its own value objects. Every microservice has its own bounded contexts. And most of the time, they do not share any bounded context, most of the time. So every service has its own bounded contexts, its own truth, and its own life cycle. If I change something in service A, I probably don't want to change it in service B as well. It should be in 2 separate services, not in a shared library. And it has its own deployment. If I'm deploying service A with logic something, I'm probably not wanting to deploy the other service as well with the same logic. And yes, bounded contexts can overlap at some point in time. And yes, they will be different most of the time. So that's the detail. Most of the time they're different and sometimes they can overlap. But you need to have the flexibility to change your domain logic into 2 different microservices. So the first one, don't share domain logic. Sharing domain logic will lead to extreme tight coupling. It will lead to having to deploy each microservice in production whenever the domain logic changes in the shared library. You have no independence. You cannot change the domain logic in service A without changing it in service B. There's no correct version management because it's in the shared library. It does not have its own life cycle. There you go, no individual life cycle. And there's no way to refactor it correctly. If you have a shared library with domain logic and you try to refactor that, you end up in a discussion, no, I need that for my API. Okay, but it's not used in mine. Is that my problem? So then you end up in the fight. Then you end up in the fight over, does it need to belong in that shared library? And the answer is, no, it doesn't. There are some exceptions on sharing domain logic. If you look at an API registry or a shared kernel in DDD, yes, there are, but it should not be part of a shared library. It should be part of an API registry with OpenAPI documentation and OpenAPI YAML or XML documents, but not a shared Java library which is compiled. And mostly this is between a handful of services, not a dozen, not 200 microservices, maybe 2, maybe 3. And if you do share logic between microservices, the couple, please keep them separated from your shared library. So if you have a shared library with some Java classes and you have some shared domain logic in an API registry, keep those separated. So the domain logic in the shared API library can be released separately from the shared library. Number 2. We're at number 2 already. Manage your dependencies. Don't create one big shared library. So you've all heard of a God class probably, which is over 2,000 lines of code, or even worse. We've all seen those probably. And What we don't want is a God library. Okay, I already have one library. Let's put it in there. Is that a good idea? No. No God library, just like the God class. Create smaller ones. Create smaller libraries for one purpose. Something like, I have a library that has something to do with logging. I have a library that has something to do with security, or I have an advanced HTTP client, just a configuration for my HTTP client. Put those in separate libraries and cluster them. Has anybody heard of a monorepo? Good. That's what I mean. Put them in a monorepo and create a multi-module project where you have all those shared libraries together. Then you can change them together, you can version them together, but they are separated. Things that change together should be together. And this is what I'm talking about. I'll give an example later in the talk, a multi-module in Maven or Gradle. Manage dependencies. So if I manage my dependencies, I should not have transitive dependencies. Who has heard of transitive dependencies? That's a lot of you. And I always try to explain transitive dependencies as I'm having a party and I'm sending an invitation. And on my invitation, there's a dress code. I want everybody that comes to my party to dress up because it's a nice party, just like last night. And only the guests with an invitation are actually welcome to my party, not someone else, not your neighbor. No, I did not send him an invitation, right? So at the invitation, I write exactly how you're welcome at my party. And if I write that down, I expect you to come like that. I do not expect you to bring someone else. If I want that someone else to come as well, I would have invited him. So if I'm having a party with a dress code smart casual, and he comes to my party looking like the left, I'm kind of disappointed. And if you bring someone else, I'm kind of disappointed as well. With dependencies in Maven or in Gradle, in Java, you can have transitive dependencies. A dependency bringing some other dependency. A dependency bringing a version 1.0 of another dependency, but the other guy is bringing version 3.0. Oh, now we have a problem. Two uncles are there. They're identical, but they're a different version at my party. That's strange. So if you have a dependency management in your microservice or your shared library, and you look up a dependency tree, it could look like this, and then it's a little messed up. What you see here is, for example, on the top left, you see A1 using J version 1, and J version 2 is being used by B2. And that's a whole big tree of dependencies with its own versions. You want those controlled. You want to be in control of which version and which dependency is in your shared library. So versioning. What can you do to manage your dependencies in your shared library? Well, create a parent POM, which means I can put dependency management in my parent POM, and that's where all the versions are specified. All my dependencies with the specific versions. Or create a BOM, a bill of materials, which means exactly the same, but they're used in a slightly different way. Eventually, the versioning is in that POM. Use the dependency management only in one place. So if you have to look up where and what dependencies in what version are used, you know where to look. Your own library should be part of that dependency management as well. Even the external dependencies are in that list. And it improves updating dependencies as well. So if there's a CVE tomorrow, which pops up, you know exactly where to change the version of your dependency. It's right in that parent POM. Next, use starters to manage your dependencies. And a starter is the exception to transitive dependencies, because the starter is a one-stop shop. The one-stop shop, if you import this dependency in your POM, you're good. You have all the required dependencies with all the correct versions. My advice would be split up those starters per scope. So if you have something that has to do with JDBC, or you have something to do with messaging, split them up in those starters, just like you did with your libraries. If you only want to have some shared library that has to do with JDBC, you'll only import that starter. If you have something to do with messaging, you'll only import that one. Also, logging and security is a good example for this. Well, nice, Willem, but can I get an example? Yeah, sure. So how would I set this up? I would create a root where only the modules are specified. And I would create a my awesome parent. It's really nice. It only contains a POM. And it contains all the dependency management. It contains all plugin management. And then I have my really awesome library. It contains the best code ever. Bug-free, by the way. And it has a dependency to the parent. The parent I just created. So this one uses that parent. It has no dependency management, no versions for dependencies in this project. That's all contained in the dependency management of the parent. The actual shared library is this. It has functional, non-functional code. And it only has optional dependencies, which means no transitive dependencies in this one. And then I have my optional starter, which means only a POM. It has my awesome parent as its parent, because I want to use the dependency management and the plugin management as well. And it contains my awesome library. So this would be, if you look at dependency management, a very clear example on how you could manage your dependencies in a shared library. And of course, my awesome library could be my awesome library 1, my awesome library 2, my awesome library 3, everything that has to do with some kind of concept, security, logging, etc. Number 3, choose the right encapsulation. My first advice would be careful with inheritance. Something that has to do with cross-cutting concerns, non-functional code, like putting in how to configure my logging, and configuration code, that has nothing to do with inheritance. A cat, a dog, or a horse, that is an animal. That is inheritance. And creating a abstract class which should be extended in my microservice, be careful with that. Try to minimize this inheritance to your real domain code in your microservices. Apply the open-close principle correctly. If you want to avoid white box reuse, you need to look at this. You need to look at any of the solid principles, by the way, but I just want to mention this one in particular. Open for extension, but closed for modification. That's what it's about. Which means, can my bean, which I provide in my shared library, can it be altered? Can every... Oh. A shared library is all about applying this principle correctly. I'm missing some text here. Excuse me. Going back to the open-close principle, If you apply that correctly, you'll see that the shared library is able to extend or use or apply whatever you've provided, but it should not change or modify something that shouldn't be changed. Just don't create protected method because I need it for test, or a protected method because microservice A needed it. No, be careful about that. Improve it with factories. Create a factory bean that creates another bean, and make sure that the factory can be replaced by another factory. So if you have a factory bean, another microservice could replace that factory bean to create a completely different instance of the bean that you've provided in your shared library. So that means it's open for extension. Use builders. Builders is really a cool way to be able to pass on to microservices. Create a simple builder in the first place and be able to extend that builder. It can be passed around. And have a look at the customizers post-processors. I'm a really big fan of Spring Boot framework. I'm not here to debate about if it's a good idea or not. The examples I'm giving here are mostly related to the Spring framework, and they're very nice to use. So if you have a look at the Spring Boot internally, they'll use factories, they'll use builders, they'll use customizers, post-processors, etc. for a reason. Because it's very extendable. Because it's that you can replace whatever you want to replace and not completely throw away the complete library. If you need to throw away the complete library, the library is useless. Don't forget, I also mentioned it a little earlier, apply all solid principles. It improves your code quality completely. And document your interfaces. We've heard documentation before, but document your interfaces. Not every method, not every private field, but your interfaces. Everything that's public for your consumers. Describe the use, describe the intention. And add annotation wherever that's possible. So add the nullable or the non-null to your libraries so that the IDE you're using can help you in, hey, you're passing a null value in here, but it can never be null. It describes actually the contract of your shared library. And it avoids defensive programming, which means I don't want to have a null check everywhere. Number 4, estimates its use. I always want to know how my library is used, right? So, who's a big ski fanatic here? Who likes skiing? Oh, cool. I'm a big ski fan as well. So, when I'm out in the harsh weather, it's really dry outside, it's windy, it's cold, I use this. Who's used this before, but not for what I just mentioned? Exactly. Without going into details, yes. Are we underestimating its use or overestimating its use? There is a manual at the back of this thing. It's in English, it's called petroleum jelly. We just call it Vaseline, but there's a manual on there how to use it, but we're using it completely different. Just like this. This could happen to your shared library as well. So, overestimate versus underestimation. That's what it's all about. Overestimation. the bunny on the left. Look how sweet. He thinks there's a big carrot. But overestimation estimation is building too much code and spending way too much time on your shared library. You're really proud. Yeah, really proud. No one uses it. No one. So you think, oh yeah, it's really good. Everybody's going to use this. No, nobody is. The other way around, you're creating something that's really, really, really fancy. You underestimate it. You don't write any tests. You forgot those or didn't have any time. You finished it. No solid principles, clean code. What's that? And you released it. And then all of a sudden, 6 other teams came to the conclusion, that's cool, I need that. And then the bugs come in. 2, 3, 4, 5 at a time. And what do? Do they change your library? No, that's too much time. I'll just copy the code and I'll change it myself. Without tests. So underestimation is not a good idea as well. You need to prevent that. And keep in mind, if you think it will never be used like that, it will. Yes, it will. So look at the library that you're making and you're creating from different perspective. Interact. Go into discussion with each other and have a discussion on how you look at this library, what should be part of it. The one says, oh, it's a boat, and the other guy says it's land, from 2 different perspectives. So if you're creating your shared library, make sure that if you release it, you add configuration with it. So it's clear how to use your library. Configuration by component, that's what I mean. Provide an application configuration within your shared library. And now I'm specifically talking about Spring Boot. You can actually, within your library, create an application configuration with your components. In Jakarta EE or Quarkus or Micronaut, you can do this as well. And auto-load it when it's present on the class path, which means that my beans or my components that I want to use, dependency injection, are configured automatically. I don't have to do anything. I don't have to look at some documentation on how I need to configure it. I don't need to add any documentation on how to move from version 1 to version 2 within my configuration. Add auto configuration. And use convention over configuration. I like that one. So first of all, you start with property-based configuration. And then you start with property-based configuration. And then you use some more properties. And eventually, you use code-based configuration. So if I end up at the last point, I'm actually wanting to overwrite some beans or some components within my shared library. But first of all, try to use property-based. And if you look at that, this example I'm trying to explain, it's based on number 3 of the 12-factor application. If you don't know what I'm talking about, I added the link and I'll upload the presentation later. And have a look at those 12-factor application. Store your configuration in your environment. So if you add a feature flag, for instance, make that a property. Make that a property that you can switch in production as well. And do not make it hard-coded that you need to recompile your shared library. Because if you're recompiling your shared library, you're releasing a new version. And somebody asks, what did you change? I set this property to false. But I need it to be true, so you need to release a new version again. And then you end up in a separate track of your shared library. So don't hard-code the configuration in your application. And if you can, use feature toggles. And who uses feature toggles in his application, in a backend application? Oh, that's a lot of you. Very nice. In Spring Boot, if we look at that example again, you can have conditional beans, which means a property will be evaluated before the bean will be added to my application configuration. And it's a good way to activate a switch on, do I need this feature, or do I don't need this feature? Use auto-configuration wherever you can within your shared library. Make beans replaceable. This means conditional on missing bean. Make beans conditional. Make them extendable. And I'm quoting this because I started the presentation with, be careful with inheritance. Yes, use factories, use builders, use post-processors, wherever you can, but not inheritance. Try to avoid inheritance. And use type-safe properties. This is really one of my favorite ones. I like type safety because this means that I can estimate the use of my library. I know how it's used, and I can validate how the properties are set by every microservice. It's a one-time conversion. At startup, my properties are converted to the right type, and I know it's correctly. I do a validity check, and what's even better is make them immutable, so that you cannot change them after you've started up your application. Once they're set, you don't want them to change. And when it's a feature flag, just what I was mentioning about, in a running application, it can have big consequences. Because if it's a bean that's reloaded with a different instance, or it's a bean that's being reloaded with additional functionality, and you're using dependency injection, you need to replace all the other beans as well. And it has big consequences. So make them, thank you, make them immutable. Provide default properties wherever you can, which makes the library by default usable. Number 5, the last one, validate the usability. We've talked about estimation, estimate its use, and now we're talking about validating the usability. And I've heard it before. What is the key in verifying the usability? Come on. Did someone say tests? Now I know why all GitHub projects don't have tests. So verify how your library is and will be used. Validate that it can be used like that in how you expect it to be used. How do we do that? Exactly, with tests. So test your shared library. Test the functionals. So if you have any functions within your shared library, test them within a unit test. But I've been talking about configuration and beans, etc. And it's even fine to test your non-functionals of those within your shared library. Within an integration test, you can test your property loading, you can test your conditional beans, you can test replacing your beans, you can test what should it do when I provide a different factory. If you expect someone to be able to do that, create a test of it. Make sure you test your feature flags as well. Yes, it's an annotation. And, oh, my code coverage says it's fine. No, it's not fine. Good tests is not all about code coverage. Good tests is about testing your library in the way you expect your consumers to use it. Make sure you add those asserts as well. Make sure you test your conditional beans. Yes, there are tests for that. Override those beans as well, and test your properties. So have you tried testing your component with a property that is not valid? Add it, add a test to your library. And if you don't do integration tests, yes, you miss a lot. You have not validated the property-based configuration. You will end up with an unexpected use of your library, which is not validated at all. You will have the risk of non-working library, and a non-working library is useless. Other teams working around the non-functionals, it's going to be a white box reuse, where it's going to be harder to refactor your library as well. If you create a shared library or a shared core component, which has several shared libraries as well, it's a good idea to create a regression test, a separate module where you actually create a fake application loading your shared library. A separate module within your root library. Test it with a fictive application. It's a consumer of your shared library, right? It's also part of your life cycle. So if you pass those tests, it can be released. There can be released a new version. Use integration test for that. So, resuming, my 5 good habits on how to create a shared library which is not ill. First one, avoid domain logic. The second one, manage your dependencies and create a good project setup where you have all your libraries in there. Number 3, choose the right encapsulation and be sure to check all your solid principles. Number 4, estimate its use, discuss it with each other, and look at how it's used. And number 5, validate the usability. So I hope this helps you on developing a shared library, a healthy shared library. And thank you, and feel free to ask questions. There's some time left right now. Thank you. So we got 5 minutes, so if there's any questions right now. That's a good question. The question is, if you have a parent POM, would it act like a God POM? Yes, actually it would. But it's actually what I want. I want that POM with all the dependency management in one place. Maybe what I understand from your question is, if you have some third-party dependency which is not used by your shared library, but it's used by microservice X or Y or Z, should it be part of your shared library? That's a good question, yes. And it's up for a discussion within your company if that's a good idea or not. Who's responsible for keeping all the third-party dependencies up to date or not? Do you want that in one POM or not? Yeah, that's a good question. The question is, what do we do if we have a parent POM with a version X of a third-party dependency, but I want to use version X.0 or X.1? My advice would be, make a property of each dependency version within your POM. Every version should be in the properties, which makes it very easy to override your dependency version. So that goes back to the open-close principle as well. Make it open to change that version within any microservice that's using your library. The question is, if there's a bug and a bug fix of your shared library, how do you notify all the other consumers of your library? I would suggest automating that. So I would suggest something like Dependabot, Renovate, or if anybody heard of Open Rewrite as well, try to automate it and automatically create pull requests automatically so that your microservices are up to date with the new version as well. So I think there's time for one more question. I'm trying to understand your question. Can you elaborate more? Oh, that's a good one. Yeah, so the question is, if I have a shared library that contains some functionality, when should that be extracted to a separate microservice? It's a good question, and it's not that I have a clear answer for it right now, but it's a good discussion. I'll be open to discuss that with you afterwards. I want to thank everybody for their attendance, and have a good day.